It's Knut here. I'm at the Norsk Racing shop to give you the behind the scenes inside scoop on toe alignment on a Radical SR3. Now before I go into the details for the tricks behind doing this, I thought I would first give you a quick demonstration so you can decide if you want to stick around for the gory details or not. So first, the car's been set up for alignment. It is sitting on a flat level surface. Those are my turn plates that you see there, and the tires have been inflated to the correct alignment pressure, and the steering wheel is straight ahead. So the car is now ready to be aligned. So I'm gonna have to set the camera down to do the demonstration. So hold on just a second while I set up. Okay, so we're ready to give it a try. I'm gonna start a little timer here and give you a sense for how quick and easy this is, and then I'll measure the alignment, the toe alignment that is, on both the front and the rear on this side of the car. Okay, the rear toe is 2 millimeters in. And the front toe is 1 millimeter out. That's all there is to it. 1 minute. Okay, so let me give you a little bit of the scoop. But let me first start by highlighting the traditional way for doing the toe alignment on the Radical SR3. Now for camber, there are really slick little tools like this that make it a triviality to get a camber measurement in a few seconds. But for toe, it's not quite as quick and easy. Traditionally for toe, I use alignment bars and strings. It's a very common setup. I have my 2 alignment bars. I've marked them. They're obviously the same front and back, but their position is different on the front and the back. On the Radical, it's common for the rear diffuser to have a couple of holes drilled in it, and the rear alignment bar simply lays across the rear diffuser and is zip tied in place at the 2 little drilled holes. On the front, Radical provides a couple of reference clips on the crash box, and the front alignment bar lays in the clips. This is probably going to fall out, and again it's zip tied in place, and then you have the 2 alignment bars, the front and the back. You then have to put the string in the little groove, and then you have to wiggle the bars back and forth until it is centered on both sides of the car. So you're out here with the steel ruler measuring the distance from the reference point to the string, and then going on the other side, doing the same thing, wiggle, wiggle, until the string is centered, and then you do the same thing in the front, and then as soon as you change it in the front, it ends up changing it in the back too, and so you go back and forth, front and back a couple of times until the bars are centered and the strings then form the square of the car. Now that's just a setup. Then when you start doing the measurement, you whip out your trusty steel ruler and you measure the distance to the string in the front, in the back, and in the front, and you subtract the two, and then you can measure what the toe is. Oftentimes, this stupid raised lettering on the wheel is going to be turned in the wrong place, and so the steel ruler, you have to obviously work around the lettering, but it's a pain in the ass, and you do that front and the back, and you can get the toe that way. That's the traditional way that I do the toe alignment, and I still do that sometimes just to double check the accuracy of my jigs. Now let me show you the quick and easy way to do it, how that works. Hi, I'm back. Had a good lunch. So the secret to this quick and easy alignment trick is a little jig that I've made, and here it is. Little piece of plastic, printed it on my 3D printer. Has a couple of different aspects to it that all combine to make the jig precise and functional. The first is it has a sleeve that slips into the wheel hub, and let me show you the details on that. So the wheel hub is the reference, and the outer lip here is the measurement reference point. And to secure like a perfectly aligned jig reference, the sleeve is a perfect slip fit into the center of the hub. Now, with the length of the sleeve and the fact that I can make it a perfect slip fit, I get a very precise axial alignment of the jig to the wheel hub. Okay? Now, unfortunately, I can't make this an interference fit, or I won't be able to push it into the hub and still be able to remove it afterwards. And so, even with a perfect slip fit, I end up with a droop. And no man wants a droop. And so I needed to create a retention scheme in order to take both advantage of the perfect slip fit for alignment and still have it be retained. So I created these little springs with a 0.5 millimeter protrusion. You may be able to see here, if I hold it just right, that there's a protrusion on each one of these fingers, and because of the slots, there's a little bit of a spring to it. And so while the main sleeve is a perfect slip fit, the springy fingers make it a tension fit. And so that then holds this perfectly in position when I push it in. So when I push the jig in, it takes some resistance, but it's retained. Now that's just one part of it. That's just having the jig be held to the hub securely and with precise alignment. Then we've got to talk about the rest of the jig. So the shoulder on the jig here, that's what actually rides up against the reference spot on the hub. And so I bottom the sleeve out in the hub until the shoulder rides on the reference point. That provides the proper depth reference for the placement of the jig. On the jig, there's a couple of notches. You may have noticed on my alignment bars that after having done that dozens of times, the front and the rear bars, they have a little scribble on them that highlight what the distance is of the string to the center of the hub, so that I don't have to go right to left and right and left in order to center the bar. I already know what the measurement is for the bar being centered. That's the same idea here. Since I know what the distances are, I know exactly where I want the string to lay on the jig. And so these notches are for placing the string on the jig. It turns out in the back, because the wheels have a deeper dish, it's the outer notch, and on the front wheels, it's the inner notch that is used. And then the next and final feature is there's a measured distance from the notch, which is the end of the string, to the measurement grid. And of course, there's a separate measurement grid for the front and the back because the strings are not in the same spot. The 0 is the groove that's between the two short fingers in the center of the grid. And so there are grooves and ridges, and I just used a little magic marker to color the ridges to give me the scale. And so the scale here allows me to see where the string is lined up in order to perform the measurement. Now, the distance between each ridge is 1 millimeter, and so the distance between a groove and a ridge is a 0.5 millimeter, and so on. Now, this is a one-sided measurement, and normally on the Radical, when you perform the toe measurement, you measure opposite sides. And so whatever the measurement here is on the one-sided, you have to double it. And so I just basically count each 1 millimeter on the scale here as being doubled at 2. And so that's easy to do by eye. That's basically all it is to the jig. And I'm going to show you again how easy this is. You just plug it into the wheel hub, and you lay the string in the notch, front and back. Make sure that the scale is not interfering with the free movement of the string. And then the string will show you on the scale exactly what the toe is. Easy peasy.